The topic is Introduction to Probability. The essential question is, can you use probability to calculate the likelihood of events occurring? So we're going to start off with the definition of probability. Okay. Probability, it's a number from 0 to 1, or you can do 0% to 100%, that describes the likelihood that an event will occur. So in other words, it's the chance or the odds of something happening measured from 0 to 1 or 0% to 100%. So see all these words you filled in? These are just keywords that would indicate, hey, you're doing probability. So when someone's saying, hey, what are the odds of this happening? That's calculating probability. Or what's the chance that this could happen? That's calculating probability. Or if you ask, gosh, how likely is this? That's probability, okay? And again, it's measured from 0 to 1 or 0% to 100% if you converted them to percentages. Because as you should hopefully know, 0 is 0% as a percentage. 1 would be 100% as a percentage. So here is something called the scale of probability, or we can call it the probability scale. And you'll see, just like we have up here, it goes from 0 to 1. And in this scale of probability, if this is 0 and this is 1, right here, as a decimal, would be 50 hundredths or 5/10. Okay? So smack dab in between 0 and 50 hundredths would be 25 hundredths. And right down here, right between 50 hundredths and 1 would be 75 hundredths. Okay? So I'm going to go ahead and convert each of these decimals into their equivalent percentage. So 0 would be 0%. 25 hundredths, that'd be 25%. Because all I'm doing is multiplying by 100. Multiply by 100. Okay? Multiply this by 100 and you get 50%. Okay, 75 hundredths as a percentage is 75%. And 1 as a percentage would be 100%. Okay? So if something has a probability of 0, that means it's an impossible event. It totally can't happen. Okay, so maybe an example would be like, if you looked out the window right now, you would see a dinosaur looking in the window right back at you. A real life dinosaur. And that's an impossible event because we all have determined that dinosaurs are extinct. Okay, so if something had a probability of 1 or 100%, that's called a certain event. Okay, and that's for sure going to happen. Okay, so if something has a 50% chance of happening, the wording for that would be called an equally likely event. Okay, equally likely. All right. And for a 25% chance of happening, that's called an unlikely event. Okay. If something has a 75% chance of happening, that's a likely event. All right. So I'm going to go ahead and show you what I have written over here in the left-hand column. And it says, to find probability, your first step that you need to do is count the total number of possible outcomes. And that's going to be the denominator. So how many possibilities are there? That will be your denominator, you know, the bottom part of your fraction. The second step, step 2, then you would count the total number of outcomes you're looking for. This will be the numerator. So, knowing about these two steps that I've just shown you to find probability, we're going to go ahead and do this example right here. It says, what's the probability that you'll pick a blue marble from each bag? Okay, so we're going to take a second, and if you don't have a blue colored pencil or marker, that's okay. But I want you to go ahead and keep these 4 marbles as white. I want you to color one of these marbles in right here, just one of them blue. I want you to color 2 of these marbles in here blue. And this one right here, I want you to color 3 marbles in with blue, okay? Then for this one over here, I want you to color 4 of the marbles blue. Because pretend that these are bags, and inside each bag are 4 marbles, okay? So it's saying, what's the probability that you'll pick a blue marble from each bag? So you'll see right here that there are no blue marbles in this bag. And your first step was to count the total number of possible outcomes. This will be the denominator. I see that there are 4. So our denominator is going to be 4, okay? Step 2 says, count the total number of outcomes you're looking for. This will be the numerator. So I'm looking here and I'm looking for blue marbles and I don't see any. So since there's none, you're going to put a 0 there, okay? Well, to find this as a percentage, you just go 0 divided by 4, and that'll give you the decimal version of the percent. Well, and then from there, you would multiply that decimal by 100 to get the percentage. So 0 as a percentage is 0%, okay? And so we know this scenario right there, that's an impossible event. That's totally not going to happen. You're not going to select a blue marble from this bag of all white marbles, okay? So this next one, again, you're going to go through step 1 and step 2. Step 1 says you need to find the denominator, which would be composed of the total number of possible outcomes. There are 4 marbles in this bag, so you're going to write 4 in the denominator. And then the second step is you're going to count the total number of outcomes you're looking for. This is the numerator. So there's 1 right there. So it's 1. 1 out of 4 are blue, okay? So to find the decimal version of this percent, you would go 1 divided by 4, which is 25 hundredths. Well, 25 hundredths converted into a percentage, you would take 25 hundredths and multiply it by 100. 25 hundredths times 100 is 25, which would give you 25%. Okay, so this right here is a pictorial representation of an unlikely event. It's not likely you're going to pick that blue marble. Could it happen? Yeah, but it's not really likely. Okay, this right here, again, go ahead and find the probability. Let's write it as a fraction first. The numerator is going to be the ones you're looking for. The denominator is the total possibilities. So there's 2 blue out of a possible 4 marbles. 2 divided by 4 gives you 0.5 or 0.50. You know, 5/10 or 50 hundredths, same thing. And you know that, hopefully you know this, that 50 hundredths converts to 50% right there. And when you have a 50-50 chance of something happening, like you might have heard, that's basically an equally likely event. Like this could happen where you grab a blue, or the white could happen. There's an equally likely chance of it happening, okay? Right here, you'll see that we have 3 blue marbles out of the possible 4 marbles, and 3 divided by 4 is 75 hundredths. Well, 75 hundredths as a percent is 75%. And you'll see that it's a likely event. It's likely that you're going to draw a blue marble from this bag, okay? This next example, you'll see that every single one of those marbles in that bag is blue. So when you have all of them, they're all blue, 4 out of 4 total marbles, that's a certain event. You know for sure when you grab a marble out of that bag, it's going to be blue because that's all there is in there. Well, 4 divided by 4 is 1. 1 times 100 would give me the percentage, so 1 times 100 is 100, and add your percent sign. So that's a 100% chance of happening. So therefore, this bag of marbles right here displays a certain event. For sure it's going to happen, okay? Now for your summary, you've got some vocab words that I want you to fill out to get, so that you get your points. So the first word is an outcome. This is what an outcome is. It's the result of a probability experiment, situation, or activity. The next vocab word is event. Event is a collection of outcomes of a probability experiment, situation, or activity. Our first example says, Mrs. Hopkins tosses a fair 2-sided coin. So I just want to take a second right now and explain what they mean by a fair 2-sided coin. When you see the word fair, like in probability and stuff, it just means it's not a trick coin. Okay, so when it's a fair coin, it's not a trick coin. I know that there are some coins out there that are both sides have heads on it, like, you know, a trick. But when it's a fair coin, it's not a trick coin. There's no catch. One side is heads and one side is tails. Okay. So we need to know what's the probability that the coin will land on heads. So when you're doing this, right here, this is how they would symbolize, like, when you're looking for the probability. So probability of landing on heads, okay? So they'll put what you're looking for in the parentheses, and then the P just outside, it means, hey, probability of this, okay? What's the probability of this happening? And again, I'm going to draw your attention to what we have over here on the left-hand column to tell you how to find probability. So you're going to count the total number of possible outcomes. This is going to be the denominator. So on a fair-sided coin, you have a heads side and a tails side. So there are 2 possible outcomes. So that's my denominator. To find the numerator, you got to count the total number of outcomes you're looking for. This will be the numerator. So I'm just looking for heads. How many heads are on that 2-sided coin? Well, there's only 1. Okay? So I would take 1/2, but I really like it when you express it several ways. So as a fraction, it's decimal equivalent. 1 divided by 2 is 0.5 or 0.50, 5/10 or 50/100. Or I would also like it if you could also write it as a percentage. So 50/100 or 5/10 is equal to 50%. And you should hopefully know that when it's a 50% chance of happening, that would be an equally likely event. Okay? Okay, the next part of the question says, what's the likelihood it'll land on tails? So you'll see that they didn't give us the support they did in the first part of the problem, so we need to go ahead and write that out. Probability of landing on tails is, well, it's the same thing because there's 1 tail out of the 2 possibilities on the, the 2 sides of the coin. So 1 divided by 2 is 5/10 or 50/100, and that converts to 50%. So again, that's an equally likely event. Now it says, what's the chance it will land on heads or tails? So something that that might make it a little bit easier for you, in probability only, the word or means add. Or add, or add, or add, only in probability, okay? So the way I'd illustrate this out, I'd write probability of heads plus the probability of tails. And once you do that, you're going to get the probability of getting heads or tails, okay? So what was the probability of landing on heads? Well, it was 1 out of 2, 1/2. And I like to keep these as fractions until I add them all together, And the probability of landing on tails was 1/2. 1/2 plus 1/2 is 2 halves, because, when you're adding fractions, you want to have the same denominator, which we do, and keep it consistent. But the numerators, you just add them together. So 2 halves, and 2 divided by 2, that's 1. Which would also be 100%. So if it's a 100% chance of happening, when you toss a coin, you're either going to land on heads or tails if it's a fair-sided coin. That's a certain event. Okay? Alrighty, for the next problem. It says that you pick 1 jelly bean from the pile without looking. What's the probability you'll pick a red jelly bean? So we're looking for a red jelly bean. Well, just like these steps up here on the left say, count the total number of possible outcomes. That's the denominator. So I'm looking at this here, and you're going to count those number of possible outcomes, and I see that there's 10. But I need to write this, probability of picking a red. I know the denominator is 10 because there are 10 jelly beans sitting right there. And now for the numerator, count the total number of outcomes you're looking for. I'm looking for red. So 1, 2, 3. Okay? 3/10. If I could have simplified this fraction into a more simple looking fraction, you could have done that, but we can't. So I'm going to keep it as 3/10. 3/10 as a decimal. When I go 3 divided by 10, I get 0.3. Oh, look, which is 3/10. That says 3/10. That says 3/10. So these are equal. And that as a percentage would be 30%. Okay, so you'll notice that on that probability scale, you don't see an exact 30%. But 30% would be like, I don't know, right about there. So I'm going to consider that an unlikely event. It's not very likely that I'm going to get a red jelly bean when I pull them out of when I'm pulling out a jelly bean. Okay, so we're going to call this an unlikely event because that's what it's closest to. All right, the next part of the question, it's saying, what's the chance you'll pick a red or a green jelly bean? So they're looking for red or green. And I hope you remembered from above that the or will mean add in probability only, okay? So I got to find the probability of picking a red jelly bean, or means add only in probability. And we'll find the probability of getting the green jelly bean. And once I add them together, I will have the probability of getting a red or a green jelly bean. So probability of red was 1, 2, 3 out of 10, as you hopefully remember because we just did that. Or typically means add in, in probability. And probability of getting a green, how many greens are there? Oh, there's 1 out of 10. So that's really not likely, just getting that green one. So 3/10 plus 1/10, we got the common denominator here. So we're going to maintain that common denominator. 3 plus 1 is 4. Look, another way I can represent 4/10. Let's go ahead and simplify it. Let's see, a number that goes into both 4 and 10 is 2. So I'm going to simplify it so it stays a fraction. So divide by 2, divide by 2, by 2, divide by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So these are both acceptable. As a decimal, you can go 4 divided by 10, or you can go 2 divided by 5. You get the same exact decimal, which is 4/10. And that converted into a percentage is 40%. Okay? This next example says, Dusty rolled a regular 6-sided dice. What's the likelihood he rolled an even number? So I see that word likelihood, so it's kind of telling me, hey, we got to find that probability of that happening. So we're looking specifically for an even number when he rolls that regular 6-sided dice. And a regular 6-sided dice looks like this, okay? So we're looking for the probability of him landing on an even number, probability of even number. And as you hopefully know, you gotta count how many possibilities there are. There are 6 possibilities that you can land on. And how many of those are even? Well, if I don't have a dice right in front of me like this, I can write down something called the sample space, also known as the possible outcomes. So what are the possible outcomes, or the sample space? Same thing, they're used interchangeably. I know that Dusty could land on a 1, 2, 3, 4, 5, or 6. And of this sample space, how many of those are even numbers? There's 1, 2, 3. 3 of them are even numbers. 3 out of the 6 possibilities. So I also want you to know that 3, 6, another way we can write that if we simplify it would be 1/2, because I divided by 3 to keep it as a fraction in its most simplified form. All right, now as a decimal, 1 divided by 2 or 3 divided by 6 gives you 5/10 or 50/100, and that turns into 50%. Okay, so him landing on an even number has an equally likely chance of happening. It's an equally likely event. So what's the chance that Dusty's going to roll an 8? So probability of an 8, well, there's 6 possibilities on that die, and I don't see any of them as 8, so that's 0 out of 8 chance, or sorry, 0 out of 6 chance of happening, and 0 as a percentage is 0%. That's an impossible event. Okay, this one up here was an equally likely event. Okay, what's the probability that he rolled a 1 or a 4? So we want a probability of rolling a 1 or a 4. Or typically means add in probability and landing on the 4. Well, the probability of rolling a 1 is 1 out of 6. I'm going to add that to the probability of rolling a 4, which was also 1 out of 6. You're adding fractions, so whenever you add fractions, you add their numerators as long as the denominators are the same. So I see I have the same denominator, so it's over 6. 1 plus 1 is 2, 2 6, which simplifies to 1/3. And 1 divided by 3 or 2 divided by 6 gives you 0.3 repeating, which is approximately 33%. Okay? So that's an unlikely event, because that's where it falls on the probability scale. Number 4. Louis spun a spinner once. The spinner has 8 congruent sections labeled 1, 1, 4, 4, 4, 5, 5, and 6. I want you to know that congruent means that they're all the same size, same shape, same angle measure, okay? And I don't know if you remember this, but a while ago I think I showed you that this symbol right here means congruent. So you got like an equal sign with like a squiggly above it, like, you know, it looks like kind of an approximate sign. So that means congruent. And we need to know which event is the most likely to occur, okay? So I'm going to go ahead and list the sample space right here, also known as the possible outcomes. And it's, you can land on a 1, 1, 4, 4, 4, 5, 5, and 6. And it's important that they said they're congruent sections, because if they weren't congruent sections, then that totally, that really wouldn't work, because you want to have your probability, each thing in your probability to have an equally likely chance of happening. So I'm going to try to draw my best circle here and make each of the sections congruent to each other, but use your imagination, because it's probably not going to turn out congruent. So there's 4 sections, and we need 8, so I'm going to cut each of those 4 in half. Ooh, whoa, that was bad. Sorry, guys and girls. All right, so I know 1, 1, 4, 4, 4, 5, 5, and 6. Okay, so we're looking for which event is the most likely to occur. Well, look at it. Which one's most likely to occur? Basically, kind of, what's the mode of this? 4. So landing on 4. Okay, it didn't say what is the probability of landing on 4. It's saying, hey, which one was the most likely? And it's the most likely because it's listed the most. You see 4 the most on there, okay? And now it says, what's the chance of the spinner landing on a 5? So now it's asking for probability, because I see that word chance. What's the chance of that happening? So probability of landing on 5, let me see how many 5s there are. There's 2 out of the 8. So 2 out of 8, or let's go ahead and simplify this fraction. Let's see, divide by 2, so 1/4. And then 2 divided by 8, or 1 divided by 4 would give you a decimal of 25 hundredths, and that would be 25%. So it's not likely that you're going to land on 5. It's an unlikely event. Okay? So down here for your summary, you have a vocab word, and it says sample space. So sample space is the set of all possible outcomes or results of a probability experiment, situation, or activity. It's a list of all the possible outcomes. Number 5 says, a jar contains 9 red marbles, 3 blue marbles, 3 green marbles, and 3 yellow marbles. Determine whether each statement correctly describes the likelihood of an event. Select true or false for each statement. So I want to start off probably, before I kind of dig into this, I want to look and see what the sample space is. So what are the possible outcomes? Let's see, there's 9 red marbles. Now I'm not going to write the word marbles because it goes with this. So I'm just going to write just the color. So 3 blue. What else did we have? 3 green. 3 yellow. Okay. So how many total marbles are there? So it would be 9, 10, 11, 12, 13, 14, 15, 16, 17. Go, 9 plus 9 is 18. Total possibilities. Okay. All right, so the probability that a red marble is selected is 1. So we have to find true or false. So let me see, what is the probability of selecting a red one? How many red ones are there? There's 9 out of 18. 9/18, I can divide by 3, and get 3/6, which I can again divide by 2, and get 1/2, or 50%. Is that 1? Nope, so that's a false one. Okay, the probability that a yellow marble is selected is 0. So let's find probability of yellow. And probability of yellow is 3 out of 18. which could also equal 1/6. And I don't think that works, right? No, it's not 0, so that doesn't match. So that's another false one. Okay, the probability of selecting a blue marble, a green marble, or a yellow marble are equal. The probabilities of those happening are equal. So let's check. Probability of selecting a blue marble, I don't know. What is that? Probability of blue is 3 out of 18, which is also equal to 1/6. Probability of selecting a green one, and that's also 3/18 or 1/6. The probability of yellow is also the same thing. So think about that. Is that true or false? So those are all the same. So therefore, that's a true one because that's what it's saying, that they're all equal. Okay, the chance of not selecting a green marble is 15/18 or 5/6. So let's see here. Not selecting a green one. So I can select everything but a green one. Let me see if these are even equivalent. So I divide by 3 to get 5, divide by 3 to get 6. Okay, so I know these are equal to each other, but I got to figure out, are they even right? So probability of not selecting a green. Probability of not green. So there's a couple ways you could do this. You could just kind of look at them and see, well, you're not green, so there's 9. You're not green, so there's 3 more. You're green, so I can't count you. You're not green, so there's 3 more. So 9, 10, 11, 12, 13, 9, 10, 11, 12, sorry, 13, 14, 15. So 15 out of 18, okay? So that's one way I can do is just go 15 out of 18 and then simplify that down to 5/6. Or another way that you can do this is you can take the probability of the whole thing, 18 out of 18. Okay, that's the probability of all of them. And you're going to subtract the probability of the thing you don't want. You don't want green. Probability of green. And the probability of green was 3/18. So 18 minus 3 is 15/18, which again simplifies down to 5/6. So yeah, that's true. Okay, the likelihood of selecting a yellow or blue marble is 60%. So let's figure this out. Likelihood of selecting yellow or blue. So probability of yellow, or typically means, add, only in probability, and blue, probability of that and that. Okay, so probability of getting a yellow one, how many yellows are there? There's 3 out of 18. I'm not going to simplify it yet. Plus probability of getting a blue one was 3 out of 18. And 3/18 plus 3/18 is 6/18, which divide by 6, divide by 6, 1/3. 1 divided by 3 is 0.3 repeating. That as a percentage is about 33% or 33.3%. I'm doing an approximate because I would have to sit here forever to write the exact one. I'd have to write 33.33333 forever for it to be exactly this. So that's why I approximated it, because I had to round it to nearest 10th. So anyway, likelihood of selecting a yellow or blue marble is 60%. No, because it's only 33.3%, and that's false. Okay, for your summary, write this out. What's the sample space of a fair two-sided coin? Okay, what are the possible outcomes when you flip a fair two-sided coin one time? Number 6 says, if you flip an American quarter 300 times, how many times should you expect to land on tails? So it's not saying what's the probability of landing on it 300 times. It's saying you have a quarter and you're going to flip that quarter 300 times. How many times should you expect to land on tails? Okay. So you'd write this out like this. Probability of landing on tails. Let's find that first. What's probability of landing on tails? On a quarter. It's 1/2, right? So that's probably landing on tails, but you're flipping that coin 300 times. So I can either write 1/2 to represent the first flip, plus 1/2 to represent the second flip, plus 1/2 to represent the third flip, and keep doing that 300 times, but there's a faster way, because multiplication is repeated addition. So all you have to do is you take that 1/2, which is the probability of landing on tails, and you're going to multiply it by the 300 flips. Okay? And you'll see that there's a fraction here, and that might freak you out a little bit, but just make this other one in its fractional form, and then it'll be a little bit easier for you. So 1 times 300 is 300. 2 times 1 is 2. Let's go ahead and simplify that. I can just go 300 divided by 2, and that's 150. 150 times. So theoretically, if you were to flip a coin 300 times, you know, an American quarter, you'd expect to land out at 150 times, theoretically. Now, if you literally just started flipping a coin that many times, are you going to land on that every single time? Maybe not. But on paper, when we do the math, theoretically, we're all going to get the same exact answer of 150 times, okay? The second one, if you flipped it 88 times, how many times should you expect to land on tails? So again, well, we're going to flip it this time 88 times. And we're looking for the probability of landing on tails. So probability of landing on tails, well, what's that? Start with that. It's 1/2. But we're flipping it 88 times. So you're going to start with your 1/2, which was the probability of landing on tails. And you got to multiply it by 88. Okay, because that's how many times you flipped it. And you'll see you're multiplying by a fraction. So you can go straight across, but it helps if you write this one as a fraction also, so that it's more clear to you. 1 times 88 is 88, and 2 times 1 is 2. Now you can divide it. 88 divided by 2 is 44 times. Okay? If you ever get a decimal, just round that decimal. All right? Okay, number 7. If you spun a spinner with 3 congruent sections, okay, remember congruent, that's important, they're equal sections. So it's like a fair spinner, it's not like one of those ones that's like uneven sections. Okay, if you spun a spinner with 3 congruent sections labeled red, white, and blue, what's the chance of landing on white? So I'm going to go over here and I'm just going to kind of, it helps me when I just draw a picture. So pretend that's a perfect circle, and then pretend that these are all 3 congruent sides. You have to pretend because it's obviously not, because I can't draw very well. And it was red, white, and blue, okay? So what's the chance of landing on white? So probability of landing on white. So you see there's 1 white out of the 3 possibilities. I can't simplify that fraction. So 1 divided by 3 is 0.3 repeating. So approximately 33.3%, or you could say 33%. The reason it's an approximate is because this, exact would be 33.3333 forever, ever, ever. But I just rounded it right there, so that's why I put the approximate symbol, okay? Alrighty. If you spun it 12 times, how many times should you expect to land on white? It's not asking you to find the probability of 12 times, no. It's saying, okay, you spin this guy 12 times, how many times should you expect to land on white? So it's similar to the problem in number 6. Let's find the probability of even landing on white. It's 1/3. But remember, you're spinning it 12 times. So we start with 1/3, which that 1/3 is the probability of landing on white. But we spun it 12 times, so 12 spins. Okay? So let's go ahead and multiply straight across here. 1 times 12 is 12. 3 times 1 is 3. Hey, 12 divided by 3, that's 4 times. Okay? That's how many times you would expect to land on white if you spun this spinner 12 times. That's theoretical probability. You're just doing the math, okay? If you literally acted it out, that's called experimental probability. But we'll get to that later. Okay, if you spun it 3 times, how many times should you expect to land on white? Okay, so instead of spinning this spinner these other times, we're going to just only spin it 3 times because that's what it says right here, okay? So again, start with probability of landing on white. Well, probability of landing on white is 1/3. So we're going to start with that 1/3 because that's the probability of landing on white. You're going to multiply it by the 3 spins. And I'm going to, since I'm multiplying by a fraction, I'm just going to make them both fraction so it's really easy for my brain. 1 times 3 is 3. 3 times 1 is 3. So that would be 3 out of 3. 3 divided by 3 is 1 time. Okay? If you spun that 3 times, how many times should you expect to land on white? 1 time. Okay, if you spun it 100 times, how many times should you expect to land on white? So probability of landing on white I think you know this by now. It's 1/3 because 1 white out of the 3 possibilities. And we're spinning it now 100 times. So you're starting with the 1/3. That's the probability of landing on white. And you're multiplying it by 100 times because that's how many times you're spinning it. And to make it easy on my brain, I'm going to convert 100 into its fractional form of 100 over 1. 1 times 100 is 100. 3 times 1 is 3. And you know we're probably going to get a decimal here. So 100 divided by 3, you get a decimal of like 33.333 or something like that. So I'm going to say approximately 33 times. Okay, so let me go ahead and show you, display that with my calculator. I had to reach for it. So 100 divided by 3. Okay, and we can't land on something 0.333 times, you know, because it's like you land on it, and that's, you want to have in this scenario like a whole number. So approximately 33 times. Okay, that's why I have the approximate symbol there. No summary for this page. Emma rolled a regular 6-sided dice. What's the probability she rolled a number greater than 4? So what helps me is to list the sample space. So I made room over here for the sample space, also known as the possible outcome. So what could Emma possibly land on when she's got a regular 6-sided dice? I guess you'd say die for singular, but it would be, there's 6 of them, so 6 possible sides on there. 2, 3, 4, 5, and 6. Okay, so that's my sample space, also known as the possible outcomes of this probability experiment. And it's wanting to know what's the probability she rolled a number greater than 4. So I'm going to go ahead and illustrate this like this. So probability of, you can do number greater than 4. Hey, look, inequalities are coming back. Okay, well, let's figure this out. So are you greater than 4? No. Are you? No. Are you? No. 4, are you greater than 4? No. 5, are you? Yep. 6, are you? Yep. So there's only 2 of them that are greater than 4 out of those 6 possibilities in that sample space. Okay, we can simplify that. 2, 6 simplifies down, it goes down to 1/3. So the decimal equivalent, 2 divided by 6, or you could do 1 divided by 3. You get 0.3 repeating, and that's approximately 33.3%. Okay? Next part of the question, what's the chance she rolled a number greater than 5? Okay, so this one was greater than 4. This one's greater than 5. Probability of a number greater than 5. So let's see. Are you greater than 5? No. Are you? No. Are you? No. Are you greater than 5? Nope. Are you greater than 5? Nope. Are you? Yes. So it's only 1 out of the 6. Okay? And 1 divided by 6, I get 0.1 with the 6 repeating. So that's approximately 16.7% if I'm rounding to the nearest tenth. Okay? Okay, what's the likelihood she rolled a number greater than 1? Okay, here's my sample space. Are you greater than 1? Well, no. Are you? Yep. Yep, 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 yep. So it's everything but 1. So probability of number greater than 1. And that is 5 out of 6. When I go 5 divided by 6, I get this in my calculator, which is approximately 83 3/10%. Okay? So the next problem is number 9. There are 72 number tiles in a bag. 15 of them are even. What's the probability that you'll draw an odd number from the bag? Oh, so we got odd. They're telling us 15 of them are even. So just so I kind of have some room over here, I can think of it as, okay, so there's 72 number tiles, right? And I got that directly from right here. That's how many number tiles there are. And I know that there's 15 of them are even. So how many of them have to be odd? Go 72 minus 15, and you get 57 of them are odd. Okay, now I think we can answer our question. What's the probability that you'll draw an odd number from the bag? Probability of getting an odd? Well, how many odd ones were there? There's 57 of them. Out of how many possibilities? 72. Let's see, does that simplify? I don't think that simplifies as a fraction. So let's go ahead and go 57 divided by 72. And I get approximately 791 thousandths, which it would be 79.1%. Okay? All right, so for your summary, I want you to make sure you bring a US coin to class tomorrow, okay? Because the next notes that we're doing, you're gonna need a US coin. So make sure you have one here at school. It doesn't have to be like a quarter or anything big and fancy. Just whatever you have, a penny would work. But I just want a US quarter because I know, or a US coin just because I know they're fair two-sided coins. I don't want any trick coins, okay? And here is your summary. How many possible outcomes are there in a deck of standard playing cards? I don't know. I don't want to know what they are. I just want to know how many possible outcomes are there in a deck of standard playing cards. Number 10 says a spinner has 6 congruent sections, numbered 1 through 6. Look, I drew it. Pretend they're congruent. Okay. What's the probability of landing on 5? So we're looking for a probability of landing on 5. Well, how many 5s are there? There's 1 out of the 6 possibilities. And as a decimal, that's 0.16 with the 6 repeating. And as a percentage, that's approximately, I'm going to round to the nearest, let's round to the nearest tenth, 16.7%. Okay, 16.7%. All right, how about landing on a 7? Probability of landing on a 7. I don't see any 7s. So it's 0 out of 6, which is 0, which would give me a percentage of 0%. That's a definite impossible event. Don't forget about this thing, okay? So right there, look at that probability scale. Okay, so the next problem, landing on a 3 or a 6. So I see or right there, got to think of or add, or add. So the probability of landing on a 3 added to the probability of landing on a 6 would give me the probability of landing on a 3 or a 6. So probability of landing on a 3 is 1 out of 6. Plus the probability of landing on a 6 is also 1 out of 6. So I got, I'm adding fractions, so I have to have a common denominator, which I do. So keep that common denominator. And then 1 plus 1 is 2. So 1/6 plus 1/6 is 2/6. And we can totally simplify that. 2/6 simplifies down to divide by 2, 1/3. So that would be 0.3 repeating, which is approximately, I'm going to round to the nearest tenth again, about 33.3%. Okay? All right, what's the probability of landing on an odd number? Okay, so let's go ahead and look up at that sample space up here, 1 through 6. And landing on odd number, well, you're odd, odd, odd. So there's 3 of them out of 6. So 3/6 simplifies to 1/2, which would be this as a decimal, which would be this as a percentage. So that's an equally likely event, landing on an odd one or an even one, okay? Landing on an integer. Well, do you remember what an integer is? An integer is any whole number and its opposite and 0, 2. Okay, so how many there are integers? Are an integer? Yep. Are you an integer? Yep. Those are all integers. So the probability of landing on an integer is a certain event. It's 6 out of 6, which would give me 6 divided by 6 is 1, which gives me 100%. And you know that's a certain event. Okay? All right. If it was spun 6 times, how many times could you expect to land on 2? Okay? Well, let's first figure out, if I spun it 1 time, how many times, what's the probability of landing on a 2? It's 1/6. So probability of landing on a 2 is 1/6. Okay? So there's 1, 2 out of those 6 possibilities. Now we're going to spin it 6 times. So we're going to start with 1/6. And again, that's the probability of landing on a 2 times 6 times. 6 spins. And I'm going to make that a fraction just because then it's easier for me to multiply straight across. So 1 times 6 is 6. 6 times 1 is 6. Hey, 6 divided by 6 is 1, which gives me 1 time. Don't put 100%. You got to think of the context of the question. If it was spun 6 times, how many times could you expect to land on 2? 100%? That doesn't make any sense. How many times would you expect to land on 2? 1 time. Okay? So be very careful when you're reading so you don't mislabel something, okay? Last one. If it was spun 300 times, how many times could you expect to land on 4? So let's first find the probability of landing on 4. Let's start like with that. So probability of landing on 4 is 1/6. Okay, so we're going to start with that 1/6, which was the probability of landing on 4. And we got to multiply that by 300 times because that's how many times you're spinning that spinner. Okay, I'm going to make that a fraction. So 1 times 300 is 300. 6 times 1 is 6. 300 divided by 6 is 50. Don't put 50% or anything weird like that. It's 50 times. See, it's asking if you spun this many times, how many times would you expect to land on 4? How many times? 50 times, okay? All right, a reminder, bring a US coin to class tomorrow. And I want you to answer this. What's the definition of an outcome in probability? What's an outcome in probability? If you forget what that was, if you forgot what that was, go back and look through your notes because I already told you. Number 11 says, if you spun this spinner, what's the probability of these outcomes? Well, the probability of landing on a 5. And I know some of you are going to be like, oh, it's 1/3, but it's not. Remember how we're all about having like a fair two-sided coin and stuff? Well, we also have to have fair spinners. And when I look at this, I'm like, whoa, that 3... that section up here is totally half of it. So we need to make it to where it's fair, okay? So this side's 3, but this side can also be 3, but see how I had to split it into the 4 equal congruent sections? That's what we gotta do, okay? And pretend that they are congruent because you know how my drawing skills are. So now, what's the probability of landing on a 5 if you spun that spinner once? Well, it's 1 out of 4. Okay, which is 1 divided by 4 is 25 hundredths, which is 25%. Okay, and probability of landing on a 3, it's 1, 2, 3 out of 4, which gives you 75 hundredths, which is 75%. Okay, probability of landing on a 3 or a 5. So the probability of landing on a 3, or means add, 5, probability of landing on a 5. We got to find that, okay? Probability of landing on a 3 was 1, 2, 3 out of 4. Plus probability of landing on 5 is 1 out of 4. Well, 3/4 plus 1/4 gives me 4/4, which is 1, which would be 100%. It's a certain event. You're totally going to land on a 3 or a 5 because look at the spinner. It's the 3s or 5s. Okay, 3 or 5. It's a certain event. Okay, what kind of event was this one right here? It's 75% chance. That's a likely event. And then what's a 25% chance? That's an unlikely event. Okay, probability of landing on a 4. Do you see a 4? Heck no. So it's 0 out of 4 as a fraction, which would give you 0, which would give you 0%. What kind of event is a 0% chance of happening? It's an impossible event. Okay. Now, if that spinner was spun 16 times, so you're going to spin it 16 times, theoretically, how many times could you expect to land on 5? How many times? Okay, we spun it 16 times, but we got to figure out, well, what was the probability of landing on 5 in the first place? Oh, it was 1/4. So probability of landing on a 5 was 1/4, right? But we got to spin it 16 times. So that's probability of landing on 5. Don't forget. But we got to multiply it by 16 because I don't want to sit there and add 1/4 16 times. So I'd be like 1/4, that's the first spin, plus probability probability landing on the second spin is 1/4 plus 1/4 plus 1 plus 1/4 plus 1/4. I'd have to do that 16 times to represent the 16 spins. This is the first spin, second spin, third spin, fourth spin, fifth, and see how that'd take forever? I don't want to do that. So instead, I'm doing this. 1/4, which is the probability of landing on 5, times 16 spins is going to give me how many times I'd expect to land on 5, theoretically. Now, hold on. Let's make this a fraction. So 1 times 16 is 16. 4 times 1 is 4. 16 divided by 4 is 4. Okay, think about how you're going to label it. 4 what? 4 times. That's how many times you'd expect to land on 5, theoretically, if you spun this here spinner 16 times. Okay, how many times could you expect to land on 3 if you spun the spinner 900 times? Now, you know I don't want to do that, so we're going to do our little multiply thing, okay? How many times can you expect to land on 3 if you spun it 900 times? So what is the probability of landing on 3? Look up there. Oh, 3/4. So you got 3/4, and we're spinning that thing 900 times. So again, this 3/4 represents the probability of landing on a 3. This 900 represents the number of spins. And since I'm multiplying by a fraction right here, I'm going to make this guy a fraction just so I can go straight across here, so it's really easy for my brain. 3 times 900 is 2,700, or you can say 2,700, same thing. And 4 times 1 is 4. Well, 2,700 divided by 4 will give you the number of spins. And what is that? Go ahead and find that. So you're going to put your number right there and write spins. What'd you get? Figure it out. Okay? All right. Bring a US coin to class tomorrow for the next thing. We're going to be doing some experimental probability where you actually have to act it out. All this junk up here, this has been theoretical because it's all just math. You're not literally spinning it or doing that, okay? All right, for your summary, I want you to write this out. What's the definition of an event in probability? If you forgot, go ahead and look it up because it's in the notes somewhere. Don't forget to answer this. Answer that. This table shows outcomes of a number cube with 6 equal sides, numbers 1, 2, 3, 4, 5, and 6. Okay, so it's a die, 1 through 6, okay? And they have 6 equal sides, so we know it's a fair die. Side 1, they landed on side 1 18 times. They landed on side 2 16 times. Side 3, they landed on 19 times. Side 4, they landed on that 17 times. Side 5, where's 5? Side 5, they landed on 15 times. Side 6, they landed on it also 15 times. So based on the outcomes, what's the number of times the number cube is expected to land on 6 if it's rolled 40 times? Okay, so let's go ahead and break down this problem. These were how many times they landed on each of the sides. So with this data, how many rolls were there? Well, you would have to count the outcomes. So add all these together, and when you add them all together, there's 100 outcomes. So that's how many times they rolled it. Okay, so like roll number 1, there is 2, so they'd add that to this section, okay, when they came up with that 16, okay? So that was just one roll. They did that 100 times, and that's how they came up with this data. So now it's saying, based on the outcomes, based on this data right here, what's the number of times the cube's supposed to land on 6 if it's rolled 40 times? So let's go ahead and narrow in on that 6 right here. So the probability of landing on 6 was 15 out of how many? 15 out of 100, okay? So 15 out of 100, that's the probability of landing on a 6. And again, we roll it, what, 40 times? So just like in previous examples, you're going to multiply that by 40. That's how many times you roll it. That's how many rolls. Okay, so I'm going to make this into a fraction. 15 times 40 is 600. 100 times 1 is 100. So we just go 600 divided by 100, which is 6, and think about how you label it. It's saying, based on the outcomes, what's the number of times the number cube is expected to land on 6 if it's rolled 40 times. So you label this 6 times. That's how many times you'd expect to land on 6 if you just rolled it 40 times. Okay? All right, number 13. This table shows the outcomes of a spinner with 3 equal sections. Remember, it's important that they're equal sections, colored red, blue, and white. Okay, so 3 equal sections. Those are equal, okay? Red, blue, white. Based on the outcomes, what's the number of times the arrow of the spinner is expected to land on the blue section if it's spun 20 times? Whenever you have these spinner problems in theoretical probability where you're just doing the math, assume it's never going to land in the middle of, like, on the line, okay? It's going to land on something. So anyway, we got to figure out how many times to get this data, how many times were they spinning it? So we're going to just add them all together, okay? And when I add them all together, that's 100 outcomes. That's how many times we spun it. They spun it 100 times. Of those 100 spins, they landed on white 31 times, blue 34 times, red 35 times. So based on the outcomes, what's the number of times the arrow of the spinner is expected to land on blue? So let's go ahead and narrow in on blue. What is the probability of landing on blue according to this data? 34 out of 100. That's the probability of landing on blue, okay? So now, if we're going to spin it 20 times, how many times should we expect to land on blue? So you're going to start with the probability of landing on blue, which is 34 out of 100. Again, that's the probability of landing on blue, don't forget. And we're spinning it 20 times. So that's spins. Okay? And I'm going to make that into a fraction. So 34 multiplied by 20 gives you 680. And 100 times 1 gives you 100. So 680 divided by 100 gives you about 6.8 times. So let's do an approximate, about 6.8 times. You can't land on it 0.8 of a time, so it's more closely, what would be more probable is like 7 times. So you could do 6.8 times, or about 7 times. That's a 7, okay? All right. Don't forget to bring a US coin to class tomorrow. And here's your summary question. What kind of event has a 100% chance of happening? When there's a 100% chance of something happening, what is that called on the probability scale? Okay, bye.